So we move on to our next lecture, which has to do about customer data and big data. And so reviewing what we talked about last time is we talked about networks, and so how it's a function of nodes, links, and topology. And in order for a network to be effective, it has to be active. And the active aspects that we look for, which drives it, is that we need trust, privacy, intimacy, and civility. That those are the kind of things that people need to want to be involved in a network, that it has to be mutually beneficial, and it raises the perceived value about it. So today we're going to talk about what data is, how it applies to marketing, how it's being implemented in some applications. And the basic concept of big data is that this is the age of data, and marketing is we make decisions, and the best decisions are based on information. But the thing to keep in mind is that everybody has these tools. And so if everybody has these tools, then what separates everyone? And what separates everyone is your creativity, your insights, figuring out what causality is. So a lot of people become married to data and they don't do a particularly good job. So what's it all about? Well, we're people. And people, the thing that we see is patterns. That's the most basic data analysis that you have. And so it's taking information, knowing what to do with it is why we survived. I mean, let's face it, if you're a lion, are you going to chase, would you rather chase that 40-mile-an-hour elk, or do you want to chase that fat man who could only run 15 miles an hour? All of this information all started because of gambling. And I've often said that one of the best experiences I ever had was at MIT was playing poker a lot. And the reason why is that on every hand you're calculating probabilities, you're looking at what's in the pot, and so you're making data-driven decisions on every single card in every single hand. And that's what Pascal and de Fermat did. And so now in this modern age we have all kinds of tools and things like DOE and ANOVA and all. But computers was the big first step, and that computers allow us to get into this data mining. In 2006, Google arguably started the modern age of data marketing, and that's they came up with the term of analytics. So this is the age of data scientists, where you go out and you collect data, you interpret it, and then you have to communicate it to others, and so visualization is very important. I remember the old days. I did a stint in operations, and every morning what do? We get a stack of data about this high of paper. So getting rid of that is a big deal by just making graphs or whatever. And the thing about data is it's impacted every single part of marketing. And so the perception is that data just belongs to nerds, but the reality it's for everyone. The computers are friendly, that all the tools are out there, and so anybody can do this. What they found is that people who are data focused do 3.5 times better than underperforming teams. Well, not 3.5 times better, but 3.5 times more likely to be successful. And so when you look at everybody who's excelled in their fields, whether it's baseball, John Henry of the Red Sox was one of the early pioneers in financial analytics. Dell Computer used data. Everybody thinks Dell started because of the internet. And that's simply not the case. Dell started before the internet. But what Michael Dell has always been very, very good at is interpreting what data means. He's always had promotions of different channels. So the basic data processes that people do is abductive, you remove data; inductive, and that's it, you generate propositions that the data tells you, points you in new directions. And deductive means that you go out and test it. So those are the three things that you do. You clean the data, you figure out what it means, and then you go out and see whether or not it makes sense. In analytics, what do? Well, prediction, what we want to use data is to predict. And so that helps us discover, to control things, to maintain it, to model it, and then to validate it and verify it. Where validation is, yes, this actually does work. And verification is, guess what? I could do it more than once. And so these are the generic functions of analytics and the foundation of Six Sigma and everything else. What happens in a minute with this, because we're flooded by data, and in a mere 60 seconds, and this is back in 2016, it's even greater than now, but like 69,000 hours of Netflix is watched. Google, 2.4 million searches every 60 seconds. And so we create 2.5 exabytes per day. Now, to tell you the truth, I always get mixed up between peta and exa. I remember the teras after giga, and that's about it. But in 2 days, we create more data than was created from the beginning of mankind to 2003. And so it just keeps getting larger and larger. Now, when I talk about paper usage, what I mean is that everybody thought, oh, with computers, we're going to live in the age of paperless. And that's actually not true. And I said, no, we're going to use more paper than ever before. And the reason why is computers have given us a way to generate a lot more information that's going to need paper. In the old days, what did you do? And I'm kind of embarrassed to admit this, but my bachelor's thesis was done on a typewriter. It's all around us. It's used for health. It's used for our home. Airlines for you Aeroastro majors, and autos. You've got a computer in your car. What do you do when you get diagnostics? First thing they do is hook it up. Shopping and crime. And they found out that basically when they study criminal patterns, they can figure out how to reduce it. And so data is just a simple part of it. Now, what is big data? And big data is that you start talking about data sets that are just so large that traditional processing technologies just don't work. Big data analytics is about what operators we apply. Essentially, how do we analyze it? And so there's different technology, different functions where we mine for data and then process it. And our challenges, and that's that supervised data, if you remember all the way back when we were talking about surveys and products and all, is that supervised is we try to do prediction based on control tests, and unsupervised is we take the data that's already there and try to figure out what it means. And so in terms of mining, we try to find useful data sets. Knowledge discovery and data mining, it's referred to. Machine learning. What machine learning is that, again, patterns. And what your computer does and what data systems do is they look for patterns. And based on those patterns, they can predict what's going to happen next. Statistics you know about, and visualization. Can you look at this data in a way that you can see what's going on and interpreting it? So the results process of big data is, what do? We collect it, we process it, we analyze it, and interpret it. And so what drives data? It's called the 5 V's. And actually, some talk about the 3 V's. There are 5, and actually there are 4 that are super critical. And one is, what's my volume of data? What's my velocity? How quickly can I get that information back? And so, like, for example, if I have stores all over the world and I want my store data, then it's not necessarily that simple to get it all that quickly. Whereas some things I could do in real time, and so I have to think about infrastructure. Variety of data. Now, when we think of data, you think numbers. But no, data takes a lot of different forms. And that data could be video, that data could be pictures. And so data takes a lot of different forms. And so everybody's trying to outcompete each other by trying to figure out what that optimal form is next. We care about the truthfulness of our data, whether or not it's accurate, and how variable is the data. Like, I get a piece of data and I say, okay, like, people are going to spend $10. Well, 2 weeks from now, are people going to still be spending $10, or is it just going to be all variable? How well is it controlled about it? So variability is sort of like the least of the 5 V's, but veracity is a big deal. In terms of volume, it's easy to create a lot of data. The question is, you got to filter out the junk. So is it relevant? Is it timely? And what's the population size? Is it optimal? An example of volume are like your credit cards, and that your credit cards can track all of your spending and your habits, and so they see what products you want to buy. Think about what happens even when you just buy one thing: the location, the amount, the time of day, the time of year. And so by looking at these habits, they have algorithms to figure out how you'll purchase. And so, for example, Amazon Prime members spend more than double actually right now than non-Prime members. So where do they get all this data? Your rewards cards, because you always put it in and swipe it. And so instead of having to wait for like your credit card to give you that information, your rewards card sends all the information directly to them so they can get it with speed. And so if you look at your receipt, there's all kinds of information. And so I can predict what your preferences are. Now in terms of another example of volume is somebody who's actually taken advantage of it is Sears. And so Sears had a problem because their promotions would take 8 weeks to collect the data, and that's like the end of the season. So what they did is they set up something simple called a Hadoop cluster. It's kind of like the equivalence of edge servers, and so they could figure out which brands were selling, their promotion time by making it more efficient, how they could collect their data, dropped to a week. And so initially they outsourced it to an integrator, and now they've brought it in-house. One little problem: Sears is really innovative using data. The problem is they still have messy, stinky stores. And so that's where, people could be all slick and everything, but, your problems are probably more fundamental. Examples of velocity, and that's that taking on data. Some marketers at work found out that they could outperform the realtor companies that can, collect these monster databases. And variety, Twitter actually accurately predicted real time and faster than the CDC about sickness patterns, because everybody's publishing it. Actually, Dr. Cho owns a cabin up in the woods, up on the Mongolian Rim, about 2.5 hours outside the Phoenix area. And for those of you who know, there were a lot of fires. And that fire got within 1 mile of my home, and I was like all stressed out. And it wasn't so much, the place was insured for fire, so if I lost it, I would get my money back. The problem is that area would have been devastated. It would have just been a char, and it probably would have taken two years for that house to be rebuilt, because everybody up there will want their homes rebuilt. And so, how did Dr. Cho track the fire? He watched Twitter. Twitter was by far the fastest than any news source or anything else to find out in real time what was going on. And so, when they asked marketers what's most important to them, they say it's variety. That's where you can get huge differentiation. You can clean up your speed. The volume of data you get, again, there's not that big problem getting data, but the variety. Where are places where I can take advantage of variety, and that's that I can use legacy sources, unstructured data, and I can look at social media. Those are good places where you can find different types of data. And so there are practical considerations in using these systems. And that's that, you only have so much money, you only have so many people to look at it. Ultimately, a person's going to have to interface with it. People have biases. And you also have to look at the context where the data was taken and what it is. And so here's a nice infographic telling you all about creation, acquisition, information processing, and business processes. And these are the type of structures that people are using right now. And so we'll learn more about data in the next lecture.